Another more normal way that people will say it is not you ate 9/4 of pizza, you ate this whole pizza right here, and you ate this whole pizza. So you ate 2 whole pizzas, and on the last one, it was cut up in 1, 2, 3, 4 sections, and you ate 1/4. Now, both of those 9/4 or 2 1/4 is the same amount, but it's just a different way to word it. Now, let's say we had this where I ate this piece, 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 and these 2 pieces. So you could count up and say there is 1, 2, 3, 4, 5, 6 slices in both of my visuals. I'm doing darker blue so you can see it. And I ate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 8, 10, 6. Or, of course, if you want to say it as a whole number, I ate 1 whole. And in this visual, I ate 4/6 of the last one. Now, you could simplify this fraction into something that's easier to work with, but we're not getting into that quite yet. So let's go to page 2, if you're with me, and we are going to talk about what happens if it actually works out perfectly. Sometimes a fraction will make a perfect whole number. Doesn't happen really often, but it can. For example, remember your bottom number tells you how many sections to break it up into. So that's 4 sections, which I did. And the top number tells you how many shade in. 1, 2, 3, 4. If you ever see the numerator and denominator, if they're the same thing, that means you ate 1 whole. Now, this problem really messes up students a lot, which I don't really understand why. It's saying, okay, you're ordering a pizza. It's broken up into 1 section. Well, 1 section, 1 section, 1 section, 1 section, and you are eating 4 slices. 1 slice, 2 slices, 3 slices, 4 slices, which means that you just ate 4 wholes. Now, another way you could also break it down is you could break it down into what's called a unit fraction. It has a numerator of 1. So let's think about this. Is how you'd actually normally eat pizza. That's the way I tell people. Unit fractions are like how you'd normally eat pizza. So let's say this slice, and this slice, and this slice. Now, normally, if you eat 3 slices of pizza, you're not just going to stack them on top of each other and take big bites. You are just going to go and eat 1 slice at a time. So let's look. My pizza is broken up into 1, 2, 3, 4 slices. So I'm going to eat, in 5 slices. So I'm going to eat this slice right here. So that's 1/5. And I'm going to eat another slice, this one. I ate 1/5. And then I'll eat another slice. Plus 1/5, and that means if I was to show it as a unit fraction with addition, it's going to look like that. Now, the whole problem, if I put it together, will be 3/5.
After-school students can report to their classrooms. After-school students can report to their classrooms.
But I'm not eating it all at once, so it would be 1/5 plus 1/5 plus 1/5, and that's how you break it down as unit fractions. Now, here's another thing that gets kind of weird, is sometimes you can have different fractions with the same values. Now, they can be shown visually or numerically, and even though they sound different and look different, it's the same amount. So let's say that you had a pizza and it was broken up into 2 sections, and you ate this top amount, and I had the exact same pizza, except it was broken up into 6 sections, and I ate this much. If you look, we both ate the same amount of light blue pizza, except you only had to eat 1 slice and I had to eat 3 slices. Yet these numbers are actually equal. 1/2 is the same as 3/6. I'm going to show you in a little bit why that works with the butterfly method. The next one, let's say you have a pizza and it's broken up into 8 sections, and you eat, doing a different color blue, 1, 2, 3, 4, 5, 6 pizzas. It's broken up into 8 sections, and you've eaten 6. Now, my pizza is broken up into 4 sections. Take a second, think about how many slices will I need to eat. One's not going to be enough, or 2, but it looks like 3 is kind of like Goldilocks' porridge, where it's the just right amount. So sometimes you can have fractions with different numbers, but it's still going to equal the same amount. And these are called equivalent fractions, meaning they're going to look different, they're going to have different numbers, but they are actually equivalent, EQUI, equal. They are equal fractions. And you can find them kind of easily through factor understanding. Sometimes they can be easy, sometimes they can be harder, but we're just going to show this with base 10 understanding. Now, what you need to remember is when we're talking about tenths, that's kind of like your dimes. And if you're talking about hundredths, well, that's kind of like your pennies. So looking at these problems, it's saying, okay, if I have 7 tenths, that's the same thing as 7 dimes. How many pennies would it take to make 7 dimes? Well, it would take 70 pennies. So if somebody had 7 dimes and somebody had 70 pennies, they would both be equal. You can also say, okay, well, 10 times 10 is 100. What's 7 times 10? It's 70. Notice they're going to be equal the same amount. Next one, go the other way. 70 pennies is how many dimes? Well, that's 7 dimes. Notice I could just divide. 70 divided by 10 equals 7. 100 divided by 10 equals 10. I could divide by the same number, both top and bottom. Or if I'm talking about thousands, which don't really exist with money, I could say, okay, well, 7 times 100 gives me 700. So what does 10 times 100 give me? 1,000. 700 thousandths is the same thing as 7 dimes. And then we'll go over some more understanding of multiplying fractions. Now, this is going to sound a little bit like division, but this sentence right here, in this thought bubble, most people are going to say 1/2 times 3. That's not what it's saying. It's saying I have 1/2 of 3. I have 1/2 of 3. So I have 3 pizzas, and I'm going to have half of those, or I'm going to eat half of it. So imagine my 3, 1, 2, 3. I ordered 3 pizzas, and how much am I eating? I'm eating half of those. They're all broken into 2, and I'm going to eat half. 1/2, 1/2, 1/2. Remember that multiplication is just repeated addition. So if I have 1/2 plus 1/2 plus 1/2, how many halves did I eat? I ate 1, 2, 3 halves. Or if you don't want to show it like that, you can say I ate 1 1/2 of the pizzas. If I put it all together, 3 halves is the same thing as 1 1/2. Next one, I have not 2 times 2 eighths, I have 2 groups of 2 eighths. So I have basically saying the same thing, except I have 2 pizzas, 1, 2, and I'm going to take 2 eighths away from each. I'm going to eat 2 eighths of my pizza. So the first thing I need to do is I need to cut up my pizza, and then I need to eat 2 slices of each. 1, 2, 1, 2. So if both my pizzas were cut into eighths, and I ate 2 eighths of this pizza and 2 eighths of this pizza, how many eighths did I eat altogether? I actually ate 4 eighths worth of pizza. Now, a big question I have with students is, how can I compare fractions to see which one's bigger or which one's smaller? And this can be done with visuals, which I'll show you here, and it could also be done numerically, which means with numbers. And if you're doing with visuals, I just want you to look at your shaded amounts. Whichever one has more shaded, that's the one that's greater. If they're both the same size, meaning I can't compare a small pizza and a large pizza. They both have to be the same size before I can even think about comparing them. So I have 2 pizzas, and this person says, well, I ate this many slices of pizza, And this person says, well, I ate this many slices of pizza. Which one has more light blue shaded in? It's actually going to be this one. Because if I was to count up my boxes, this person ate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. His pizza was cut into 16ths. And he ate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. He ate 12 16ths of his pizza, while this person's pizza was cut into 2 even sections, and they ate 2 whole slices, which kind of means they ate the whole thing. So obviously, that's going to go that way. What about this one? What happens if this person ate this much pizza, and this person ate this much pizza? Well, this guy's pizza was cut into 2, and he ate 1. This guy's pizza was cut into 8, and he ate 3. But who has more dark blue shaded in? Well, it's going to go this way. That guy, even though he ate slices, his slices were so much smaller than the other person's. He actually ate 3 slices of less pizza than that guy's 1 slice. Couple things you need to remember is that your polygons, it could be a square, it could be a circle, it could be a rectangle, they have to start the same size. You can't compare a small pizza and a large pizza. And you are only comparing the shaded amounts. Doesn't matter how big or small the pieces are, it matters how much is actually eaten. Or what we could use is called the butterfly. Now what you're actually doing with the butterfly is finding a common denominator, but that's more of a 5th grade kind of thing. And what you could do is you can circle a numerator and the opposite denominator and multiply. 7 times 2 is 14. Multiply the other numerator and opposite denominator. 8 times 1 is 8. And you just see which is bigger. Which is bigger? 14 or 8? 14. Goes that way. Butterfly again. 1 times 16 is 16. 2 times 11 is 22. 22 is larger than 16. Last one. Butterfly, 9 times 12 is 108. 11 times 10 is 110. It's going to go this way. And this whole foldable work, math today, this is only to focus on the review stuff from 3rd and 4th grade. Once you get into 5th grade material, once you get into 6th grade material, it does get a little bit trickier, but if you can remember these concepts, you're going to do just fine. Thanks for watching. Don't forget to like and subscribe.